Welcome to the video where we're going to be simplifying some expressions that involve exponents. And that's the one that I know students get confused with, but don't worry, we're going to work with this example step by step. First, you might not even see any exponents here. We're just working with the fraction 18yz all over 30xyz. In this case, if you're told that y and z are not, let's not even together, that y is not 0 and z is not 0, then you can actually divide by y, z in the numerator and denominator. What else do we want to simplify here? Well, we also can't divide by whatever you see in common that 30 and 18 have. I would say that I would divide by 6, right? So I can divide 18 by 6, that will be 3, and then 30 by 6, that will be 5. Now look at the coloring. What stays there? So this fraction becomes, let me move this away. This fraction becomes 3 and 5 stay after I simplified 18 over 30 by dividing everything by 6. Then yz disappeared, right? Not disappeared. We divided by y. Y over y is 1. I will even write down ones for you. Z over z is 1. And then x in the denominator stays. So the answer is 3 over 5x. Does that make sense? So again, we divided by 6 and we divided by yz if y and z are not zeros. From now on, we need to know the formulas for exponents. And the formulas for exponents are a to the x times b to the y. Let's first do with the same base. A to the x times a to the y is a to the x plus y. So if you multiply, if you multiply and you can see that we have the same base, a and a in both cases, then the exponents can be add up. A to the x over a to the y will be a, guess what we're going to do instead of adding? Exactly, subtracting, x minus y. And finally, a raised to the x and raised to the y. That's the only case when you actually multiply the exponents. Moreover, if you have many of them, say it's going to be 7 raised to the x, raised to the y, raised to the z, and so on, you can rewrite it in a more compact form. X times y times z. Amazing. And that's exactly what it means. And that's why those notations are pretty cool. Also, if you raise a to the 0 power, that gives you 1, but only if a is not 0. Or else, what is it going to be? 0 to the 0? We actually will be kind of learning this in Calculus 2 class. What else interesting to know is, for now actually that's all. So we're going to be using those formulas, and let's put each of them in the box. So you need to remember this, and you will see them quite a lot. They're very handy. So for the first example, we're working with a fraction z cubed y to the 6 over z to the 4 y to the 6. And for number 7, I would see it this way. So there are many ways to see it. Either you use the formulas I just showed you, then it's going to be, so I'm using formula number 2. With the formula number 2, I will have z 3 minus 4 times, then I see it like this, like couples. And then I see y 6 minus 6, that's kind of what it is. So the answer for this case will be z to the minus 1 raised to the y to the 0. If we assume that y is not 0, and it is in the denominator, so we assume it's not, then y to the 0 using formula number 4, so let's number them. Using formula number 4, y to the 0 is just 1, so the answer is z to the minus 1. Z to the minus 1 can be rewritten, let me add this formula. A to the minus 1 is 1 over a, again if a is not 0. Put it in the box, that's a good formula to know too. Formula number 5. So I can rewrite it as 1 over z, like this. And that is the answer. If you don't feel like you're liking this method, let me show you a different one. We could just do this way. Z cubed times y to the 6 all over z to the 4 times y to the 6. And then take a small pencil, maybe with different color. And then you know that y to the 6 and y to the 6 can be cancelled out. That means we're dividing by y to the 6 and the answer gives me 1 right away. And we also know that z cubed and z to the 4 can be cancelled out. But how? Only 3 will be cancelled out. So whatever gonna stay is 1. How do I know that? Because I'm kind of working with z cubed over z cubed times z. Check the formula number 1. The formula number 1 says that z cubed times z1 will give you z3 plus 1. That's 4. That's exactly what I'm doing here. And now you can cancel out z cubed and z cubed. So the answer is 1 over z, which is the same thing. Choose the method you like. Seems like the second method was faster than the first one, but it doesn't really matter. It's just matters of your imagination and which way you prefer. One more example, which is example number 8. Let's see what it asks. Example number 8 says simplify 42u squared over 7u to the 6. Well, first of all, I can see that I can simplify 42 and 7. 42 over 7, that's 6. 6 stays in the numerator because 42 is in the numerator and 7 is in the denominator. U squared and u to the 6. You can divide by u squared, then instead of 6, I will have 4 left. And then u to the 4 stays. How come this is the case? Because you can always imagine that we are working with u squared at the top and then u squared times u to the 4 at the bottom. U squared and u squared goes away, which means cancel out, which means we're dividing by u squared. And then 6 over u to the 4 stays, and that is the answer. Don't worry, with practice you'll become really fast at that. Now, what is going on here? Here I will show you one more formula to know, which is when you're working with A and B and C and they all multiplied and everything is raised to the power, say, x. Then you can actually move or basically distribute this x into everywhere here in each exponent. Then the answer will be a to the x and b to the x and c to the x. And usually we're going the other way around. Usually when you see the notation a to the x times b to the x times c to the x, you want to make a shorter notation. And that's how this notation was created. A times b times c, everything raised to the x. So that's the idea. Let's put it in the box as well and remember. So we will be using this right now in my next example. Since I can distribute 4 everywhere, I'll be doing it carefully. By carefully means putting parentheses everywhere. I will be repeating it quite a lot. Minus 3, put parentheses. Put 4 over here. V squared, don't forget, put parentheses and 4. U, put parentheses if you want to, and 4. Actually, the last parentheses are not necessary. But again, why not to put it there? Now, you use the formula number 1, which actually is not number 1. That's the formula number 3, I think. Yes, the formula number 3. If you're raising a to the x, and then to the y, and then to the z, and then to the m, and so on, you can multiply out all the exponents. So in this case, minus 3 to the 4, for now we're going to leave it as minus 3 to the 4. But what I want to talk about is this piece. V squared, and then raised to the 4 means it's going to be, so minus 3 to the 4, V2 times 4, not plus 4. That's very important. Think about that. If So I'm going to compare versus v to the 2 and v to the 4 multiplied like this. Then you'll have v to the 2 plus 4. But v to the 2 and then raised to the 4. That's the one, v to the 2 times 4. See the difference? Well, I will leave it like this. I can even put parentheses for you if you want. And then u to the 4. Let's simplify. What is minus 3 to the 4? Well, either you use the calculator, or you just think about that as 3 times 3, and then 3, and then times 3. That's 9, and that's 9. And then the answer is 81. You can ask me, where did I miss negative 1? Well, negative 1 can be factored out outside of all this product and raise it to the 4. Negative 1 to the 4 is 1, because 4 is even. Negative 1 raised to the even is 1. But negative 1 raised to the odd is negative 1. So negative 1 cubed is negative 1. How come I factor out negative 1 like this? Why not? Or you can also see it as negative 3 times negative 3 times negative 3 times negative 3. It's just a little bit too much writing if you think about that. And either I can see it as 4 negative signs, and that's why I have minus 1 raised to the 4, right? Because minus 1 times minus 1 times minus 1 times minus 1 is negative 1 to the 4. Or I see it negative 3 times negative 3 still gives me 9. Negative 3 times negative 3 still gives me 9. And the answer is 81. The result is the same. So it's all about your imagination, how you see it. Be creative. Mathematics is indeed pretty creative. 81 times v, 2 times 4 is 8. And finally, u to the 4. That's the answer. Put it in the box. Next example. In this example, I recommend you to pause and do it by yourself and then compare with my solution. So x raised to the negative 2 and then raised to the positive 7. That means I will multiply negative 2 by 7. And the answer will be x to the negative 14, which is already a good answer. However, if you are told that you need to write your answer without using negative exponents, and this exponent is indeed negative, then you need to use the property I mentioned before, which is number 5. As you can see, the property number 5 tells you that this negative sign you see will put x in a denominator. So now x will be positive 14 raised to the positive 14, but in the denominator. Both answers are good, but if you have instructions not to use negative exponents, you're required to put x in the denominator if it used to be in the numerator with negative exponent. Interesting point. What happens if it's the other way around? If I have 1 over x to the negative 14, then this negative will put x back into numerator. So it's going to be x to the 14. Very interesting. So just for you to know. Negative sign basically changes the location of your function or input in this case with respect to the location of the fraction, top or the bottom of the fraction. So it's just put it on the other side. That's what I would say. Now, what it is here? I think it's overlapping. Yes. How about here? 11. For the 11, we're going to use properties I already used before. In this case, it's going to be 5 squared times w squared. And that's actually all we can do. 5 squared is 25. W squared. So what I did, I basically distributed this exponent into the terms inside of the parentheses. And you can do it only because there is a product or division inside. You cannot do it with 5 plus w squared. You cannot do it that simple in this case. In this case, you need to use a square of sum, which is 5 formula. Square of sum formula. 5 squared plus 2 times 5w plus w squared. We're going to do it in a different video, so you can check it out later. But that's the square of the sum formula. So compare. Not the same thing. And I would say that's the most common mistake students do. 12. For 12, we need more formulas. What kind of number of the formula is going to be? Let me check. So let me call this 6. Then I will have 7. Formula number 7. In this case, I will write down this way. A raised to the x over y can be rewritten in this way. And this is how I remember it. X is located at the top of the fraction. That's why x should stay at the top. Y is located at the bottom of the fraction. That's why I will write a square root, and it's not square in this case, it's y root. And kind of I imagining that y is lower than x, even though in my writing it's not the case, and it doesn't have to be. But that's just mnemonic rule to remember it. X was at the top, so it should stay as the exponent at the top. Y was at the bottom of the fraction, so it will go to the root. You can also rewrite it as a root with y, and then everything raised to the x. That's the same thing, and now it's very visual that x indeed is at the top, and y is kind of at the bottom. So that's how I remember it. Let's see what it means in these kind of examples. W raised to the 8, and there's a square root. So let me add the example here. If I'm working with a square root a to the x, how can I rewrite that? Well, it's going to be a fraction, we know that. X is at the top here, so it will be in the numerator of the fraction of the exponent. And then there's a hidden 2, because a square root called squared, because there is a not written little 2 stays there. We just don't write it because it's too common and it's too annoying to type it all the time. So it will be like this. That's actually a very good example. So this is how you can rewrite square roots. And in general, the square root of a is a raised to the 1/2. So that's what I'm going to call example 4. I will do it 7a and 7b. Now, for the example here, I'm working with a square root. W raised to the 8. So I know that 8 will go to the top. The square root has this hidden 2 over here. Then I will just have 2 at the bottom of this fraction. And now I can simplify it. 8 over 2 is 4. So actually we're working with 8 to the 4. That's what is happening here. Very interesting. There is one more way to see it. You can see that the square root of 8 to the 4 times 8 to the 4. So 8 to the 4 and 8 to the 4 are both inside of the square root and they are multiplied. 4 plus 4 is 8. Then, as you can remember, for example, 2 times 2 inside of the square root, that's 4. Square root of 4 is 2. Or in general, if you have the same factors inside of the square root, then 1 just goes away and the square root disappears. That's the definition of the square root, I would say. So that's why the answer is w to the 4. This way is kind of faster if you understand it though. But this way over here, using properties, is more official way to solve it. Very good. Finally, write the following as a radical expression. Radical expression here means using radicals. Radicals are these guys, roots and so on. So, I already explained you. B raised to the 5 over 8. Since 5 is at the top of the fraction in the numerator, it will stay there. B will be sent into the root. So it's not very looking nice like this. Either you put parentheses or you write down 5 and then the root. Both answers are good. And the last example, simplify your answers here. So let's see what I can do here. As I already mentioned to you, 1 over a can be rewritten as a to the minus 1 if a is not 0. Well, I have 1 over 32. Can we rewrite 1 over 32 as 32 raised to the negative 1? Yes, we can. I told you negative 1 sign kind of flips the fraction. It sends 32 into the numerator in this case. Now I'll put huge parentheses, these ones. I just copied them. And I will put 3 over 5 since they used to be there anyways. Now I will use the property I saw already before I showed you, where I can multiply this negative 1 and 3 over 5. Or I can maybe use something else. Maybe I want to flip the order and write down as 32, raised to the 3/5. And then to the -1. That's good too. I just flipped the order, as you can see. Why not? Then I'm using the definition of how to write radicals. 32, 5, so 3 will be outside, right? Like this, and at the top, but the root will be 5th root. The 5th root of 32. That's exactly what we can calculate. But don't forget, there's still -1 happening outside. It will be outside. Like this. -1. Here it is. So, what is the 5th root of 32? You can check if I'm right or not, but it is 2. Let's check. 2 times 2 times 2 times 2 times 2. You can use your fingers sometimes. 2 times 2 is 4. 2 times 2 is 4. And 2. 4 times 4, 16. 16 times 2 is 32. Matches. So don't be ashamed to calculate by hand. Why not? You don't always have to use a calculator. Very fast. It's a very nice mind, some algebra in your mind, which actually makes you smarter a little bit. So a 5th root of 32 is 2. But 2 raised to the 3 and then raised to the -1. So 2 to the 3 is 8. Raised to the -1 and then -1 sends 8 in a denominator. This first step was actually not necessary. If you don't like it, you don't have to do it. But I noticed many students do not like working with the fractions when they're working with exponents. So technically speaking, you could actually just calculate 1/32 raised to the 5th root, like this. Let me make it bigger. 1/5th root of 32, and all raised to, what did we have? Cubed. That's the same thing, I would say. This is the same thing. Just -1 is missing, because now we have a fraction and 1/, part, and then the whole piece with 32 is in the denominator. Like we already know, the 5th root of 32 is 5. So I will have, not 5, 2, and there's cube outside, and that's 1/8, because 2 times 2 times 2 is 8. So way 1, way 2. Not too bad. 2 ways are both good. And this last example hiding over here, I will call it 14b, so it was 14a, 14a, 14b. 14b is 9 raised to the -3/2. Let's think about that. First of all, I would put parentheses over here, but it's not necessary, but then it's more visual what is happening. So, negative means that 9 should go into the denominator with 3/2 in the exponent. That's what negative piece means. Next, I'm going to rewrite 9 to the 3/2 as 9 a square root. Why does a square root? Because it's half at the bottom. Half means a square root, right? Remember? 9 to the 1/2 means a square root of 9. And we know that's 3. But don't forget about 3 and the numerator of that fraction. So that's cubed, raised to the 3rd power. I'm talking about this 3. It moved over here. Now, the square root of 9 is 3, so I have 3 cubed. Finally, 3 cubed becomes 27. 3 times 3 times 3 is 27. And that is the answer. That's all. The more you practice these problems, the more comfortable you get with exponents. And just try your best to remember these formulas I wrote for you. And make a nice list of these formulas we want you to know. This list will keep growing with time, of course, but the more you look at this list of formulas, the more professional you become at this, and at some point you will not need the list anymore. At some point, I used the list as well, and now I just remembered all of these properties and formulas. So I'm highly recommending you to create basically a cheat sheet, which you might not be able to use during the exam, but the more you look at it, the more you'll remember, and that's good. Thank you for watching this video, and see you next time.